This project has been in the making for several years, but it finally took shape in the year 2009 when the government decided to set up this body called the Unique Identification Authority of India with the mandate to give a unique ID number to 1.2 billion people. So all residents of India would be eligible for this number. This happened sometime in January of 2009, and I joined this outfit in July 2009, exactly 4 years back. And so when we took it up, obviously it was a fairly big challenge. How do you give a unique number to a billion people and all that? And I think before we go into the solution, we need to know why we're doing this. Why would you do something crazy as this? And the reason is actually quite simple, that unlike in the West, where people have many forms of identity, they have a birth certificate. In Western countries, 98% of births are registered at birth. They have a passport, a driver's license, a EU card, whatever. Lots and lots of IDs. In India, there are a lot of people who don't have any ID whatsoever. And this challenge is because right at the root, at the time of birth, registrations are not that effective. And there are many states in India where more than half the births are not registered. So as a result, you have millions of people out there who don't have an acknowledgement of their existence by the state. People do have things like ration cards, but that's a state level document. It's a family document, so it's got a bunch of names on one ration card. People have voter ID cards, but that's not portable and that's over the age of 18. So there are some IDs, but it doesn't really solve their fundamental ID challenge. Now historically this may not have been a big deal, but with increasing mobility of people with their aspirations, people moving from villages to cities, from central India to coastal India, from north to south, lack of identity is actually becoming a huge bottleneck for the future, because without ID they can't really do anything. They can't get a job, they can't get admission, they can't, they can't get their entitlements, they can't open a bank account. So fundamentally, ID creates a divide between the people with ID and the people without ID. And as I said, the people without ID runs into hundreds of millions of people. It's not a small number. So the challenge was, how do we bring all the people who are left out from an ID perspective into the formal system, into the formal society, and give them an ID to start, and then they can get on with other things in their lives. And that is really the purpose of this. It's really, think of it as the world's largest social inclusion program, where millions of people are being given an ID for the first time in their life, which is recognized by the state, and that's the important thing. But the real challenge we had was, how do we make sure, if a billion people are going to enter the system, and these billion people don't have any a priori data about their ID, how do we make sure that everybody just gets one ID? Because unless we establish a unique ID for everyone, then this ID system is not really going to fly, because if somebody can get 100 IDs or 1,000 IDs, then you lose the whole purpose of having an ID system. So the challenge for us was, how do we make sure that everybody gets only one ID? And it could not just be reliant on them saying that they have not enrolled before, because if somebody wants to game the system, they could go and enroll multiple times, and they could enroll under different names, and we would know. So the basic problem is, when you don't have something, how do you make sure that you establish uniqueness? If you're in Sweden or something, and there are 6 million, 8 million people, and they all have birth certificates, you can use that birth certificate as the basic root ID, with which you can give them an ID, but you can't do that here. So we came to the conclusion that the only way that we could do it on a scalable, sustainable, and accurate basis was to do biometric deduplication. We said that if a person has, so we said, what is the basic set of biometric details for a person which is sufficient to establish uniqueness across 1 billion people? Now this has not been done before, so we'll find out whether it works or not. But we came to the conclusion after a lot of analysis that if we really looked at the digital patterns of the iris, both the iris as well as the digital patterns of 10 fingers, there's sufficient digital diversity in that pattern to make that a unique digital signature for 1 billion people. And therefore, when we designed the system, we said, apart from taking the name, address, date of birth, and sex, we'll also take all the 10 fingerprints, we'll take the iris of both the eyes, and we'll have a photograph. So that's really the broad contour of the data we collect. We also, people do give their email IDs and phone numbers so that we can communicate with them, but that's all optional. So the basic sort of mandatory information is name, address, date of birth, sex, and biometrics, which is 10 fingerprints, photograph, and the iris of both eyes. Now, therefore, what we do with this data then is we do a process which is really the technological heart of the system. I know that Pramod talked about it yesterday. It's called biometric deduplication. So what happens in biometric deduplication is when somebody enrolls into the system, their biometrics are compared against the entire gallery or entire array of people that we have to see whether those biometrics are repeating in the system. And if they're repeating, we know that is a duplicate, it's somebody trying to enter again, and therefore we reject that. So you enroll into the system, you give all this information, your demographics and your biometrics. We run this process called biometric deduplication. If the person is a new person, we give him a number. If the person already has a number, we reject that person. That's how it works. So while it's simple conceptually, it's obviously very complex, very sophisticated to implement because it's all about the scale. So let's say today we have, say, 300 million people in a system, and let's say 1 million people enroll that day into the system. Then each of those million who have enrolled has to be compared against all 300 million on all biometric features. So that leads to several trillion comparisons every day. Now the number itself is nothing but a 12-digit number with a checksum in it. We can go up to 100 billion numbers, so that is enough. We don't have to reuse numbers. But what's important is that this has been designed as a digital ID. Because we said if we're going to design a system in 2011, there's no point giving a piece of paper. It's really important to give people a digital ID. So this number is not only a physical ID, everybody gets a letter. The real strategic value of this number, it's a digital ID. It's a number on the cloud. And therefore, since it's a number on the cloud that's associated uniquely with the person, we also provide various ways of verifying at a point of transaction that this person is indeed the person he claims to be. And this act of verifying that the person is indeed the person he claims to be is called authentication. So we can authenticate a digital ID of a person at a point of contact, at a point of service. Now this authentication can be done in several ways. We can authenticate using the fingerprint. We can authenticate using the iris. We can authenticate using a one-time password which is sent to your mobile phone. Or we can authenticate using a demographic detail like your name or date of birth. So there are multiple ways of authenticating that we provide. The authentication only answers the question, are you the person you claim to be? So it doesn't really share data about you with anybody. You basically come in there, say, my name is X, my number is 123, and you supply an authentication attribute, whether it's biometric, demographic, or OTP, and the system pings our database and says, okay, the person standing there in front of this service agent is indeed X by verifying that biometric or whatever attribute. So it's a yes-no system. You can't say, give me his address or give me his anything. It just does a yes-no. And therefore, it's a very simple system that on one side provides enrollment at scale where we can enroll a billion people at the rate of 1 million a day. And on the other side, it provides online authentication of identity using variety of biometric, demographic, and OTP kind of attributes. Now, these authentication capabilities of biometric and OTP and all that are made available as open APIs. So we believe that ID verification is fundamental to a whole host of service delivery and other kind of apps. And therefore, we wanted to build an open platform which allows different partners of ours, be it in the public or the private sector, to use ID verification in their apps. So therefore, all these are available as APIs. So you have authentication APIs. Those APIs can be called on a mobile phone, a smartphone, a tablet, a PC, or whatever device that you have. It's completely open. And we have interfaces for various kinds of devices. So somebody building an app can therefore, whatever be the logic of his application, at the point that he needs to verify the ID of a person, he makes a call to our system. The person gives his attributes, we give the answer, and the program continues. So this ability to create apps by using ID is a very important part of the design of the system, which is why it's not about a card, it's not about a physical token that you get, because we think that physical tokens are limiting by nature, because you can only do so much with the token, but it's actually the strategic value of this. It's an ID number on the cloud, which allows you to verify or authenticate wherever you are on the cloud using a variety of devices at the access point, and an open architecture of APIs which allows different people to build applications around this ID system, which could be for a variety of purposes. So that's the whole thing here. So the way it works is that the UID itself essentially runs the architecture, the technology, the standards, and the backend. And everything else is done through our partners. And we have many types of partners. The immediate set of partners we have are called registrars. Registrars are banks, state governments, or companies who have an interest in sprucing, cleaning up their ID part of the database. So these are large organizations, state governments, so on. And we have an ecosystem of enrolling agencies, which are certified and empaneled bodies who are authorized to do enrollment on our behalf. And these enrollment agencies can be public, private companies who invest in the enrollment station, which is a PC with a bunch of devices. So they buy this stuff, and they get business from these registrars to do enrollment on their behalf. So you can think of UID as the core of the system which drives the technology platform. There's maybe 50 registrars who are our partners. They in turn hire 100 enrollment agencies. And the enrollment agencies, on behalf of the registrars, open enrollment stations around the country. So it's a highly scalable linear model. You can open any number of enrollment stations. So currently we have about 25 to 30,000 enrollment stations that are live across the country. We just launched a few hundred in Bangalore 2 days back. So this whole system is a 100,000 person ecosystem, but run by a very small team of people who sort of manage this whole thing and define the standards and the contracts and the interfaces and the liabilities and all that stuff. Now, what are the possible applications of this? Now, there are many cluster applications that will emerge for this platform, and some of them are getting done, some of them will happen in the next 5 to 10 years. And we expect a lot of innovation to happen around this platform because we don't know what applications are going to be conceptualized by various people. And therefore, we expect a thriving ecosystem to emerge around this platform. And I think my friend and Chief Architect Pramod talked about it, but I'll just give you a comparison with GPS. Now, in the year 2000, in fact, on May 1st, 2000, under President Clinton, the GPS was put in the commercial domain, which meant that anybody could build a GPS receiver and do this pinging of the system to check the location. Now, today we know that the GPS ecosystem or the GPS economy is a very large economy. It runs into maybe hundreds and billions of dollars of market value. Your Google Maps uses GPS. Self-driving cars use GPS. Location-based services use GPS. Foursquare uses GPS. Inertial navigating systems in planes use GPS. All that GPS fundamentally did was answer the question, where am I? But once it was put out for innovation in the public domain in 2000, within 5-6 years, you had all these apps that nobody had ever thought about. So today we have built this whole GPS economy, so to speak. So we visualize a very similar situation where around the Aadhar platform in the next 5 to 10 years, lots of applications will emerge which will be built by the government, by public sector agencies, by private agencies, by young innovators, and they will all require ID verification, and therefore they'll come out with applications which we can't even visualize today. And that's the ecosystem that we hope will emerge in the next 5 to 10 years. And we believe that this is very important to our strategy because ultimately if we're going to get 1 billion people on board, we need to create a virtuous cycle between people enrolling into the system and the use of the number. And therefore we think that as more and more people have the number, more and more people who want to provide services will build applications that use that number. And as more and more people build applications that use that number, then more and more people will get the number because they want access to the application. So the applications and the enrollment will create a virtuous cycle which will create the momentum for us to get everybody on board in the next few years. So this is a part of the original strategy of this whole thing. There are only two uses of it, authentication and KYC. Authentication is when you go somewhere and say, I am X, my number is 123. And the system takes some attribute, sends it to our server, and the reply you get is a yes or a no. So data about you is not shared, it's just a yes or no. The only time data is shared when you again authenticate and say, I authorize UID to release my KYC to the bank or whatever it is. So there's no random movement of data. It's happening only when a resident participates in a transaction and authorizes data which is shared. That's point number one. Point number two is that this system is not open to the internet or something. This system actually has a ring of what we call as authentication service agencies, who in turn have authentication user agencies. So let's say in a financial transaction, the authentication service agency is NPCI or Visa or MasterCard, and the authentication user agency is a bank, SBI or ICICI Bank. And the customer is going to a registered device of the bank to do the withdrawal. So it's really 3 hops before it comes to us. So there's a whole host of things. We don't really expose our data to the world. There are lots of concentric rings of security. And then there are a lot of other things to address man-in-the-middle encryption. And plus we have a big fraud analytics group to look at fraud. We also have a model where every time you authenticate, you get an SMS on your phone, which is like when you do a credit card transaction. There's a whole host of things I don't want to get in here to address these kind of concerns. One is that it has your biometrics. But what we do is the biometrics is not used except for enrollment, deduplication, and authentication. Second, whenever you authenticate, okay, the system knows where you are. But that's about it. Your mobile phone is far more dangerous. Your mobile phone knows exactly where you are. Your mobile phone, somebody is able to listen to your conversation. The mobile phone triangulates your GPS. So it is designed, in fact, to be very secure and very limited usage. And it is designed to be a federated architecture. In other words, when the UID is used, say, in a banking application, what banking transaction happened is only known to the banking system, not to the UID system. Similarly, if you use a UID to authenticate to access a medical record, the medical information is only known to the medical system, not to the UID system. So it's not like one database with lots of data. It's only an ID database which is used in different transactions. So that's the cleanest, best way you can really create privacy management, by creating a federated architecture. But unless there's collusion among everybody, you really will not be able to concatenate your activities. I remember when President Reagan was asked about the size of the budget deficit, it's big enough to, it's too big to worry about, or it's big enough not to worry about kind of thing. So it's all such a big problem that I can't worry too much about it. So, it's big enough to take care of itself. Let's put that. So I think certainly there are a lot of challenges. I mean, right now our goal is to execute well. Enroll 1 million people a day, generate the numbers, print the letters. Just the sheer logistics and supply chain complexity is massive. So that's what we are grappling with, and making sure that we give the right level of customer service, because we do have backlogs. Then we have our law is with Parliament, so the law has to happen. We have to essentially make this sustainable. We also have to make sure that it's irreversible, so that it sort of stands the test of time. So there are a number of those kind of things that we are worrying about right now. I think the fundamental, when we began, the question was, is this doable? Can you do this on 1 billion people? And those are the things that were. So I think we have cracked that. Now we know we have a linear architecture that can scale up to 1 billion. So a lot of the technology challenges that were there have sort of been cracked. And similarly, the business model, how to create an enrollment system, all that has been sorted out. So a lot of that early progress has happened. But now it's about sustenance, sustainability, it's about irreversibility, it's about, putting it on a proper foundation so that it doesn't get it's stable. Then let me come to the last one point, which is how this helps in changing the equation between the individual and the service provider, which is really a source. Now today what is happening in India, and it's probably true in other parts of the world, is that markets give choice to the middle class. People are purchasing power, right? So, those of you who were around when before liberalization, you could only buy one car, two makers of car, you could only fly on one airline, you could only do this and all that. And obviously, it was difficult because you had no choice, you had monopolistic service providers. And then what liberalization did was create a choice for you. So instead of now only going to one public company for a phone, you can, you have 10 mobile companies coming to you to sell. So the bargaining power has shifted from the service provider to the individual. So it's become a competitive market. Now, unfortunately, in public services, there's no competition because a person can only go to one location to get his service. So for example, if you are a member of the public distribution system, your name is there in one shop in one village, you can only go to that shop in that village to get your rice. Or if your record is in the healthcare system, you can only go to one public health center in your village to get your service. So fundamentally, you're locked into one point. What this whole thing does is that it liberates the whole thing by putting the identity on the cloud and then linking the service to the identity. Essentially, wherever you can go in the country to do, wherever the world actually, you can go to verify identity, your service can go there. So for example, if you look at our direct cash transfer, once we hope to have 500,000 to 1 million of these micro ATMs around the country in the coming years, you as a customer can go to any one of those locations to withdraw your money. But two things happen with that. Many things, but one of them is gives you convenience. You can withdraw money in your village, next day you come to the city, you can withdraw money in the city, just like you can go to any ATM in the country and withdraw your money. But the more important thing is that it eliminates the bargaining power of the service provider. Because if a particular service provider gives me poor service, I just go to somebody else. Exactly the same way you operate in the market. So I think fundamentally changing the balance of power between the service provisioning and the individual is really at the heart of empowerment. So one of the big things that we see happening, and we'll see that now in the financial services side, is that people will get money into their bank accounts and they'll get an SMS on their phone saying their money has come, and they can walk in anywhere and withdraw their money. And that changes the whole, the relationship between state and the individual. And to us, that empowerment, beyond just the ID empowerment, is very, very critical part of this. So I think, therefore, I think, you have to think of this as a platform, as a long-term, strategy to fundamentally reinvent the way public service delivery is done. Obviously, it's a very large project. We have had lots of challenges on this project. We have backlogs of enrollment because we have more packets than we can process. We have backlogs of letter delivery because we can't handle so many letters. So we have had lots of challenges in the project. But fundamentally, notwithstanding those challenges, it's absolutely on the right track. And we do believe that it will have a major impact in the coming years. Thank you very much.